Welcome, my student, wherever you are. We have started a series of KCSE paper 2 sure bet questions. This one you will not miss them. So I want to promise you around that marks in paper 2 that you are sure about. The grid below, the present part of a periodic table. Study it and answer the questions that follow. Letters do not represent the symbols of the actual element. So whenever you have this grid here, you need to know how to label this one from number 1 to, so it means you must have the first 20 elements overhead. So you should know that this one is hydrogen, that's number 1, number 2, number 3, 4, 20. So these are the first 20 elements. So you are asked what name is given to the group of elements to which C and F belong. So C and F is here. This is C and this is F. So you can see that this is group 2 elements. So group 2 elements. This is group 2. So what name are they given? These are called alkaline. So the name is alkaline earth metals. These are called alkaline earth metals. Don't write alkali because alkali metals is group 1. So group 7 here, this is 1, 2, 3, 4, 5, 6, 7 here. Group 7 here, they are called halogens. They are halogens. So those are the things you need to know in the periodic table. And then remember that this is 1, 2, 3. This is period 1, period 2, period 3, period 4. Which letter represents the elements that is least reactive? Least reactive. The element which represents the least reactive is A. Why? Because A is in group 8. And we know that elements in group 8, they don't react because they are stable. They have electron configuration rate of 2 or 2 to 8 or 2 to 8, 8. So they are stable, they don't react. So it means that the answer here is A. They forgot to write you explain because you need to explain why you are telling that. You say that because the element do not gain nor lose electrons. In other words, you can say the element is stable. Electronic configuration of that element is stable, so it doesn't react. As simple as that. What type of bond formed between B and E? So you go back and look at B and E, the bond between B and E. So B is here, B is carbon, and then you can see that B is carbon and E is, this is number 16, that is sulfur. That is sulfur. So it is a reaction between carbon plus sulfur. These both of them, they are nanometals, so it's going to form CS. So what bond is between them? Both of them are nanometals, therefore they are going to form covalent bonds. They are going to form covalent bond because both of them are nanometals, therefore the bond is covalent. If the bond is covalent, you need to explain why. Because they are sharing of electrons. So you say they form, the reason is that they form bonds by sharing of electrons. They form bonds by sharing electrons, and that is it. Write the formula for the compound formed when D and oxygen react. So you go back to D, you check which one is D. Which one is D? Let us go back to the table. D is number 13, and that number 13 is aluminium. Number 13 is aluminium. So aluminium, when it reacts with oxygen, they form aluminium oxide. Aluminium has got a valence of 3, oxygen has got a valence of 2. So they interchange, so we will have this one. So they will form aluminium oxide. And then you need to use the letters that were given. Therefore, it is going to form D, which represents aluminium, and then oxygen. So oxygen will put 2 here, and aluminium will put 3. So this is the formula of the compound that is going to be formed. This is the formula of the compound that is formed. On the grid, indicate with a tick the position of element G, which is in the third period of the table, and as G negative. So the charge is -3 and the period 3. So we go there to period 3. Period 3 is here. So this is period 1, period 2, period 3. So we see an element here that forms such as this aluminium will form positive. So that element must be here, number 15. So because 15 is 2 to 8 to 5, that is phosphorus. What happens during a chemical reaction? It is going to gain 3 electrons to be stable. So it is going to gain 3 electrons to be 2 to 8 to 8. Therefore, if an element gains electrons, it becomes negatively charged. So the element is in period 3 and it is number 15. Therefore, you indicate number 15. The element is here because it was element G. So number 15 here, you write G. So they said you like this. So that's where that element is. Study the information in the table below and answer the questions that follow. Substance H, J, K, L. We have the melting point. Melting point -17, 8, 78, 23 to 19. Boiling point is there. So substance H is very soluble in water, J is very soluble in water, K insoluble in water, L slightly soluble. The density of each of them has been given. This one is the same as this is 0, so it equals 0.077. This one is the same as 0.00133. This is the same as that. So it is important to analyze the table that you have been given. Which substance would dissolve in water and could be separated from solution by fractional distillation. You should know the conditions necessary for separating a substance using. So for these two substances, 1, they must have different boiling points. 2, the boiling point must be close to each other. So now water, we know the boiling point of water is 100, right? So this substance that we are going to dissolve in water and then separate using this formula, this method, it must be close. It must have a temperature that is different but close to 100. So you go to the table and check there. So look at H, it has a boiling point of 78, J -33, K 77, L 188. So the boiling point that is close to that of water is 78.78. Therefore H will dissolve in water because it is soluble. You can see it's soluble in water and then can be separated by fractional distillation because they have close but different but close boiling points. Therefore the answer should be H. Reason is that H has a boiling point of 78.5 degrees, which is close to that of water, hence can be separated by fractional distillation. Which substance is a liquid at room temperature, and when mixed with water, two layers would be formed. So two layers would be formed, which means it is insoluble. It is insoluble. So therefore K, you can see it is insoluble in water. So definitely this one is going to be K. So the answer is K, because you can see there it is insoluble. So if it does not dissolve in water, then that one is the best answer. They will form two layers. So the answer here is K. Reason is that it is insoluble. It is insoluble in water. Next question. Which letter represents a substance that is a gas at room temperature and which can be collected over water method? So a substance which should be collected from Form 1 should be slightly soluble in water. So that is the keyword that will help you. So go back to the table and check which substance that is slightly soluble in water. Then when you look at it, you find that L is slightly soluble in water, K is insoluble. The other two are very soluble. Therefore, the correct answer should be L, which is slightly soluble in water, because we know a gas that is collected by over water method should be slightly soluble in water. So therefore, this one gives us the answers. L, slightly soluble in water, because it is slightly soluble in water. Which substance that represent which substance by downward displacement of air, which can be collected by downward? So a substance which is going to be collected by downward displacement of air. Remember, downward displacement of air is upward delivery. Upward delivery. For a gas to be collected by that gas must be lighter than air. So if it is lighter than air, it means it is less dense than air. So let's go to the table and check which gas is there and is lighter than air. We have been given the density of air as this. So you analyze the density of air is 0.00129. So we go back to this one and check which one is less dense than that. So you can see L is 0.013 and the that of air was 0.012. So this one is somehow denser. It is denser than air. L is denser than air. K is very dense than air. Look at J. J is 0.07, meaning it is less dense than air. So J is the collected gas that is going to be collected by upward delivery. So here the answer is J. Why? It is less dense than air. It is less dense than air because any gas that is less dense than air is going to be collected by upward delivery. So you can see now the way they combine a question and bring Form 1 work inside. So this is periodic table that has gone to chemical families. From chemical family they have taken you back to Form 1. So you need to understand this concept from Form 1 to Form 4 in chemistry for you to be able to answer these questions. Organic chemistry question. That's another question that you must be there in paper 2. So give the name of the compounds that are shown below here. So which compound is this? First count the number of carbon atoms. Here we have 1, 2, 3, 4. So we have 4 carbon atoms. We have 4 carbon atoms. Now that one can be an alkane, an alkene, an alkyne, and alcohol or alkanoic acid. So what will tell you that what type of this one? You look at the functional group, what we call the functional group. So the functional group here is OH, and the OH is an alcohol. So if these are alcohols, then which name that is given for an alcohol with 4 carbons? Definitely it is going to be butanol, right? Butanol. So butanol is the alcohol, but is that the name? No. Look at where the functional group is. The functional group is on carbon number 1. Therefore the correct name is butan 1-ol. So butan 1-ol is the correct perfect name for you to score the marks. Look at the compound number Roman 2 it's given as COOH. So which compound is this? These are alkanoic acids. These are alkanoic acids. Then look at carbon numbers 1, 2, 3. These are 3 carbon atoms. So if there are 3, then that one should be 1, 2, 3. Therefore remember the ethanoic acid, butanoic, propanoic. Therefore this one is propanoic because 3 is propanoic. Then look at the next one, Roman 3. Which compound is this? When you see this compound written in this way, you should know that this one is an ester. You should know that this one is an ester. So esterification, the process is esterification. So which ester is this? Look at this is 1, 2. So the alcohol from which they combined with alkanoic acid, ethanoic acid is 1, 2. So this one is going to be, the name is going to be ethyl. It's called ethyl. Ethanoate. This is the process, is esterification. You need to know that. Describe a chemical test that could be used to distinguish between Roman 1 and Roman 2. So how can you distinguish? How can you differentiate between an alcohol and an alkanoic acid? How can you distinguish that? So describe a chemical test that can be used to distinguish between substance 1 and substance 2. Substance 1 is butanol and propanoic acid. So put the ethanol and put the alcohol and the alkanoic acid in separate test tubes. Add a spatula of sodium carbonate or sodium hydrogen carbonate to each of them. So effervescence will be produced or will occur in the test tube containing the CH, the alcohol, the alkanoic acid. Where the test tube with alkanoic acid, effervescence will occur. And the test tube which containing an alcohol, no effervescence will occur. And that will be able, will help us to differentiate that this one is an alcohol and this one is an alkanoic acid. So in alkanoic acids, effervescence is produced when you add sodium carbonate or sodium hydrogen carbonate. But a test tube containing an alcohol like butanoic acid, like butanol, there is no effervescence. In butan 1-ol, there is no effervescence. Study the information in the table below. Number of carbon atoms per molecule, relative molecular mass. Write the general formula for the hydrocarbon. In the table. So the general, we have been asked you to write the general formula, but look at here. So how will you tell that this is the general formula? tumepewa kuna number 1 iko na carbon mbili, so carbon mbili, each carbon inakuanga na 12, so that is 24. Sawa, but the total mass is 28, so 20 ukitoa hiyo itabaki 28 minus 24 itabaki 4. So inamaanisha the hydrogen there are only 4 of them. So which element, which organic compound will be that? Will it be an alkane, an alkyne, or an alkene? So check. So if we put C2 here, then H4, that's what we have. Carbon ni mbili, hydrogen, so carbon 12 times 2 is 24. So inakuwa the mass ya carbon peke yake ni 24, lakini total mass ni 28. So yenye mebaki ni hydrogen na ni 4. Kwa hivyo this one. So which one is this? Unaona hiyo, like this one is ethene, which is C double bond C and then H. That is it. So the general point the general formula for alkenes is CnH2n, and that is it. So we have known that these are alkenes. You can even do with the third one and confirm. Predict the relative molecular mass of the hydrocarbon with 5 carbon atoms. So 5 carbon atoms, you simply write C5H 2 times 5 from the formula. That one will give us C5H10. You just use the formula you have created there, and you will tell us that the second one is this. So we have been asked to predict the molecular mass. So carbon, if this is the form, the compound, then carbon, 1 carbon is 12 times 5 plus hydrogen times 1. So this one is going to be 60 plus 10, and that one will be 70. The molecular mass for the 50 carbon will be 70. Determine the molecular formula of the hydrocarbon in determine the molecular formula for this one and draw the structural formula. So we will determine that. So that one is C5H10, and the structural formula is 1, 2, 3, 4, 5. And we put a double bond there. Here we will have hydrogen, there we will have hydrogen, 1, 2, 3, 4. Here we will have 1 hydrogen. This is the structural formula for pentene. And that is it. That is the structural formula for that. That is the structural formula for that one. Study the scheme below and answer the question that follows. So when you are given this one, you need to, you can say this is alkyne. So 1, 2, this is actually ethyne. This is ethyne. So ethyne will undergo step 1 to form. You can see this one is ethane. So ethane has been formed from sodium ethanoate. So from sodium ethanoate, this is a laboratory preparation of alkanes. So the conditions that we need here, we need soda lime, which we call sodium hydroxide. So that's what the condition necessary for ethane to move or to react to form ethane. The process is hydrogenation, addition of hydrogen. So here we need hydrogen, And then the conditions that we need there is the catalyst, nickel catalyst, and the temperature of between 150 and 250. So that is for step 1. Then step complete combustion. So when organic compounds undergo combustion, we know what they form. So if this one is going combustion, is going to form carbon 4 plus water. Then we have ethane to step 2. It is going to form 1, 2, there is a Cl here. So it means there's an addition of HCl. There's an addition of hydrogen chloride gas. So this one will undergo a certain process, step 3, to form this. What is this? This is a polymer. So the process here is polymerization. Polymerization. Now, before even you go to the questions, you need to analyze the diagram like that, and then you are able to answer the question. Name the reagents used in step 1. Step 1, we need hydrogen. So in fact, excess hydrogen will take us to alkene and then alkyne. Step 2, which is condition we need hydrogen chloride. We need hydrogen chloride gas for step 2 to occur. Step 4, what reagent? So here we have not asked the conditions. The next question now will be the conditions. What are the conditions for step 1 to occur? What are the conditions for step 2 to occur? Now, I already have said for hydrogenation, we need nickel catalyst and a temperature of 150 to 250. So that one here, this question has not asked that, but it is important you know. Hydrogenation, step 4. Which one is step 4? Step 4, that is the formation of alkanes in the lab. Laboratory preparation of alkanes, we need the soda lime, and that soda lime is sodium hydroxide. Explain one disadvantage of continued. Before that, write an equation for the complete combustion of this. So this one is C2H2 plus oxygen. So this one is going to form carbon dioxide. An organic compound undergo combustion to form carbon dioxide plus water. So we need to balance this equation. We have 2 here, so we put 2 here, we put 4 here, so that this one now becomes hydrogen here. They are put 2 here to remove this odd number here, 1, make it 2, and then this one is 8 plus 2, which is 5. And that one is now balanced. You liquid, gas, and this one is a gas. Explain one disadvantage of continued use of items made of compound formed by step 3. Compounds formed by step 3, we go back to step 3 and check which compounds are that. So step 3, these are, you can see these are polymers. So it is a polymer. If it is a polymer, what disadvantage do you know about polymers? Polymers has got one main disadvantage. It is that they pollute the environment because they are they don't decompose. So they don't decompose. They are non-biodegradable. So you just write that environmental, they cause environmental pollution. They cause environmental pollution because The items are non-biodegradable. Non-biodegradable, in other words, is that these items, they don't decompose. Therefore, they cause environmental pollution. Another sure bet question we want to look at is electrochemistry. Electrochemistry question will not miss in any chemistry exam. So electrochemistry. Electrochemistry. We need to look at questions in electrochemistry. Look at this question. Use the standard electrode potential for element A to F given below to answer the questions that follow. Elements do not represent the actual symbols of elements. Now you see A plus, this is equation like this. You can look at these equations. Now I want to tell you one thing, that the most positive and the most negative will produce the highest EMF. So when you look at this element F and element A, because the most negative is A, the most positive is F, this one, when you combine them, they will give you the highest EMF. When you see C is 0, 0, and that one is our reference, and that one we know our reference electrode is hydrogen. And then you need to know that the more the negative, the more the reducing agent. The electrode potential with the higher negative value is more reducing power. It is more reactive. Therefore, it will give electrons. The more the positive an element is, the more the oxidizing agent it is. The more the oxidizer it is, the less willing to give electrons, so it will undergo reduction. Which element is likely to be hydrogen? Give reason for your answer. The element that is likely to be hydrogen is C2. Why? The reason, hydrogen, we know that hydrogen is a reference electrode. Is a reference electrode whose E standard value is 0.00 voltage. So we know that. So whenever you see the one which is 0.00 volts, then it tells you that one is hydrogen and it is the standard electrode potential. Which is the E standard value of the strongest reducing agent? The strongest reducing agent, I have told you, it is the one with the most negative. So you can see the most negative, they want E, so that is negative 2.90 V. That is the most reducing agent, right? In the space provided, draw a label diagram to obtain C, when B and D combine. B and D combine. Now we have been told B and D. Now look at B. B is negative 2.38. D is positive 0. So it means when we are going to draw, B is going to give electrons, D is going to receive electrons. So you draw electrode, you put the electrode into and then you remember to draw the salt bridge. You draw the salt bridge, and then you draw the electrode in this side. Then you remember to draw the voltmeter here. Once you have drawn that, the most important thing is to tell us what is inside here, and which one is going to be B, which one is S. And the name this one is the salt bridge. So if I say that this one is B, then the solution inside here should be P positive, the ions of that. And if that means this one is going to be D, and the solution here should be D positive. The electron should be moving from where to where? From B to D, because B is more reactive. It is going to give it is the one that is going to give electrons, and this diagram is completely perfect for you to get 3 marks. The next question is to calculate the EMF for the cell above. So this one is EMF is equal to E standard of reduction minus E standard oxidation. We have said which one will undergo oxidation. B will undergo oxidation, D will undergo reduction. So you go and write the E for the reduction was positive 0.34 minus into minus. That one for this one was negative 2.38. So this one is the same as 0.34 plus 2.38, and that one will give us 0.272 volts, and that is the EMF for this cell. During electrolysis, 2 amperes were passed through. Write the equation for the, so we are reacting copper 2 here. So the most important thing is the copper ion. So copper 2, which is in a solution, we add 2 electrons, it will lose this one to form copper metal. So that is the equation that you need to know how to write. Because it is in a solution, it is in an ions form. So this one is aqueous. It will lose 2 electrons to form, it will regain 2 electrons to form this one. So it will undergo what we call, this is reduction. It will regain 2 electrons to form copper. Determine the mass and the anode, the mass at the anode. But we know before we go, we must get the quantity of electricity will be equal to I times time. I represent the current, so the current is 0.2 times time, which is 5. We times 60 to make it to minutes. When calculating this one, time must be in seconds. Time is a must to be seconds. So when you multiply this, you get 3600 coulombs. When you multiply that, you are going to get 36 coulombs. But we know that 1 Fahrenheit is equal to 96,500. But copper, it has 2 Fahrenheit. The charge is 2, so it means it has 2 Fahrenheit. 2 Fahrenheit will be what? 2 Fahrenheit will be 193. This times this, it will be 193.00 coulombs. So 193 coulombs has a mass of 63, because that's 1 mole, which is equal to 63.5 grams. So we will ask, what about 36 coulombs? How many grams will it be? So you multiply, so that is 36 times 63.5 divided by 193, and this one will give us a mass of 1.18 grams. So that is the mass that will be produced during this electrolysis. By the end of the lesson, we shall answer this question.
A certain carbonate supposed to be reacted with dilute hydrochloric acid according to the following equation, and this is the equation. 1 gram of this carbonate was dissolved in 50 grams of 1 molar hydrochloric acid. After the reaction, the solution needed 30 centimeters cube of 1 molar sodium hydroxide for neutralization. We will be given the density of HCl is 1 gram per centimeters cube. The first question, calculated the number of moles of sodium hydroxide that reacted. But before we go there, it is important that you understand what kind of reaction is this. Now, this HCl is reacting with the carbonate first, and the remaining HCl is going to react with sodium hydroxide. It means that this acid was in excess. It is more. Therefore, it will react with 1 gram of the carbonate. After the reaction is over, the remaining HCl is going to react with 30 centimeters of 1 molar sodium hydroxide. It is important to understand that. Therefore, calculated the number of moles of sodium hydroxide that reacted. That one is directed from here. We have been given that 30 centimeters cube of 1 molar sodium hydroxide reacted with the excess acid. Therefore, how do we get? We have been given the molarity of sodium hydroxide. It means that this is 1 molar. It means that 1 molar means that 1 mole, this is the moles, because molarity, you understand what is molarity. Molarity is the number of moles in 1 liter. So it means that this one is in 1,000 centimeters cube. We will find out that centimeters cube will contain how many moles, because that's what we want to calculate. So that is 30 times 1, we divide by 1,000, and that one will give us 0.03 moles. So the number of moles that reacted with the number of moles of sodium hydroxide that reacted with excess HCl is 0.03. It is very important to know that. When you have molarity, I can give you another formula you can use. There is a triangle here which says like this, because we have here, right here, molarity. The space is very small. Let me increase this space. Molarity, volume in liters. This volume must be in liters, moles. So how do you can use this formula and you will get the same answer. How? So we have the molarity of sodium hydroxide, which is 1. We have the volume, it is 30, and then we want moles. So how do you write this one down as moles equal to molarity, let me use M, times volume in liters. The volume must be in liters. A liter, so it is in centimeters, we convert to centimeters, to liters per 1,000. So it will be 1 times the volume, which is 30, divided by 1,000. This one will give you 0.3. So you can as well use this triangle. It is important. Part 2, determine the number of moles. Determine the number of moles of hydrochloric acid used in the reaction with the carbonate. Remember, the number of moles that reacted with the carbonate, we don't know that, but we can get that. First, we were given that 1 gram of the carbonate was dissolved in 50 grams of 1 molar hydrochloric acid. So first, let us find the volume of the hydrochloric acid, the total volume that was used, where the X carbonate was pressed to react. We have been given, we know that the density is equal to mass over volume. So we want the volume, the density we have been given, that is 1. So 1 equal to mass, which is alright, we have been given the density of the acid as 1 gram per centimeter cube. It means that 1 gram of the acid is in 1 centimeters cube. So we will find out 50 grams of the acid will be what? So it will be 50 times 1 centimeters cube, 50 grams, divided by 1 gram. So gram, we will have 50 centimeters cube. In short, when we have the volume given in grams, it is as good as centimeters cube when the density is 1, when you are given the density. So you should know that. So now we have that 50 centimeters cube of HCl was used. So we know the molarity of the acid, it is 1. Therefore, it means that 1 mole is the number of moles in 1,000 centimeters cube. What about 50 centimeters cube of HCl that was used? 50 times 1 divided by 1,000. This one is going to give us 0.05. Remember, this is the number of moles of the original HCl. Now we want to know the number of moles that reacted with the carbonate. Remember, the remaining HCl that was in excess, the number of moles is 0.03. Why? The ratio of sodium hydroxide and the HCl is 1 to 1. So you should know this. Sodium hydroxide, which reacted with excess HCl, the ratio, the sodium chloride plus water. The ratio is 1 to 1, meaning that the number of moles of sodium hydroxide will be equal to the number of moles of HCl. We know the number of moles of sodium hydroxide is 0.03. It means that the number of moles of excess HCl is 0.03. Now, if this is the number of excess HCl and the total number of moles was 0.5. Now, what will be the number of moles of HCl that reacted with X? Itakuwa 0.05 subtract 0.03. Therefore, the moles that reacted with the cup of HCl that reacted with the X carbonate is 0.02 moles. Very important. Next question, calculate the relative molecular mass of X carbonate. Relative molecular mass, RFM, of X carbonate. Now, we know that the mole ratio from the equation, we have this equation, the ratio of the X carbonate with HCl is 1 to 2. That's what I've written here. But we know the number of moles of HCl was 0.02. So what will be the number of moles of the carbonate? The carbonate will have a half of the number of moles. Therefore, moles of X carbonate is a half times 0.02. And that one will give us 0.01, and that is the number of moles of the X carbonate. Remember the first triangle in the topic moles, the concept mole. We have the RFM, we have moles mass. How do you calculate RFM? So RFM is equal to mass divided by moles, which is equal to mass. Remember, the mass of the carbonate was 1 gram. 1 gram of the carbonate was dissolved in its 50 centimeters cube. Therefore, the mass is gram. Therefore, 1 divided by the number of moles, which is 0.01. This one will give us 100. Therefore, the RFM of the X carbonate is 100. Hence, give the relative atomic mass of X. So we want to calculate the relative atomic mass of X given that carbon is equal to 12, oxygen is equal to 16. So X carbonate will give us the RFM, which is 100. But X we don't know, so X plus carbon, which is 12, plus oxygen is 16 times 3, will give us a total of 100. So X plus 12 plus 48 will give us 100. X plus 60 is equal to 100. So it means that X will be 100 minus 60. It means that X is equal to 40. Therefore, the RFM, or the relative atomic mass, the RAM of X is 40. 20 centimeters cube of a solution containing 4 grams per liter of sodium hydroxide was neutralized by 8 centimeters cube of dilute sulfuric acid. Calculate the concentration of sulfuric 6 acid in moles per liter, right? So we want to find the concentration of sulfuric acid in moles per liter. Anytime you hear the word concentration in moles per liter simply means molality, because molality is the number of moles in 1 liter. So whenever you hear concentration in moles per liter, it means molality. I have given this triangle here. So first, let us get the concentration or the molality of sodium hydroxide. Sodium hydroxide is written as this. Sodium hydroxide is that way. And we can get the RFM of sodium hydroxide at 23 plus 16 plus 1, which is equal to 40. So how do you get the molality of sodium hydroxide? So molality, the formula is here. Molality would be equal to mass, which must be in grams per liter, divided by RFM, divided by RFM. Now we were given the solution containing 4 grams per liter sodium hydroxide. So we have that 4 divided by the RFM, which is 40. So the molality of sodium hydroxide is 0.1 capital M, or 0.1 mole per liter. Per liter. 0.1 mole per liter. That is what we call molality or concentration in moles per liter. Now that we have the molality, let us see the relationship. So you must write the equation so that you can check the mole ratio. But before that, let us know the number of moles of sodium hydroxide that reacted with the sulfuric acid. How do we know? Now we know the number of moles in 1,000. We will ask what about 20? We will ask that here, that 1,000 centimeters cube of sodium hydroxide contains 0.1 moles. This one. What about 20? This volume here, centimeters cube of sodium hydroxide, the one that reacted, will contain how many moles? So that is 20 times 0.1. We divide by 1,000, and that one simply gives us 0.002 moles. So the answer is 0.002 moles. Yes. Next, now let us check the relation. So we have to write the equation, a balanced equation. So sodium hydroxide reacting with sulfuric acid, it gives us sodium sulfate plus water. Plus water. So we need to balance the equation. Sodium here, there are 2, so we put it 2 here. How many nitrogens? These are 4, so we put another 2 here. But we have the number of moles of sodium hydroxide, which is 0.002 that reacted with this. Now, since the ratio, the mole ratio of sodium hydroxide and HCl is 2 to 1, it means that moles of sulfuric acid that were used here equal to a half, because it is 1. So a half of times 0.001 which will give us 0.001. So the number of moles of sulfuric acid is 0.001 using the mole ratio. Stoichiometric equation, you need to understand that. But we know the volume of HCl of dilute sulfuric acid that was used, 8 centimeters. So it means this number of moles, 0.01, is in this. What about 1,000? As simple as that. So we will ask, 8 centimeters cube of sulfuric acid contains 0.001 moles. We are asking to calculate the number of moles in 1 liter. So we will ask, 1,000 is 1 liter. Centimeters cube of sulfuric acid will contain how many moles? 1000 times 0.001 we divide by 8. This one will give us 0.125. Capital M stands for molarity, and the molarity is moles in 1 liter. Moles in a liter. Our next question: sodium hydroxide pellets were accidentally mixed with sodium chloride. Yes. 8.8 grams of the mixture were dissolved in water to make 1 liter of solution. 50 centimeters cube of the solution was neutralized by 20 centimeters cube of 0.25 molar sulfuric acid. Write an equation for the reaction that took place. So it is important for you to understand that a mixture of sodium hydroxide and sodium chloride, this mixture, if the mixture formed a solution and the solution is reacting with an acid, the acid will only react with the base, sodium hydroxide. So the reaction is between sodium hydroxide and note the impurity. This one is just an impurity, sodium chloride. No reaction will occur with sulfuric acid. So let us write the equation. It is HCl, sulfuric acid plus sodium hydroxide, which will form sodium sulfate plus water. So that is the equation which will take place. Calculate the number of moles of the substance that reacted with sulfuric acid. So they are using the substance because they are not supposed to tell you that it is sodium hydroxide that reacted with sulfuric acid. You should know that a base will react with the acid and not the salt. Sodium chloride is a salt. However, that is why they are calling it a substance. So we know now the substance that is sodium hydroxide. So we want now the number of moles of sodium hydroxide that reacted with sulfuric acid. We have been given the concentration. We don't have the concentration of sodium hydroxide, but now we know the relationship between sulfuric acid using this equation. So we will start from what we know, the known to the unknown. We know that 20 centimeters cube reacted with it. So we started there that we have the molarity of sulfuric acid. So moles of sulfuric acid first. That's what we know. We know that 0.25 capital M stands for moles in 1000 centimeters cube, because this is molarity, and the molarity I have said that it is the number of moles in 1 liter. So 0.25 moles are in 1000. What about 20 centimeters cube, the one that was used? 20 centimeters cube will give us which number, how many moles? So 20 times this divided by this will give us 0.005 moles. Since now the mole ratio for sulfuric acid and sodium hydroxide is 1 to 2, it means that the number of moles of sodium hydroxide is going to be twice the number of moles of this. So moles of sodium hydroxide is 0.005 times 2 because of the ratio. This is 1 and this is this. What about 2? This one will give us 0.01 moles. That is it. Calculate the number of moles of the substance that would react with sulfuric acid in 1 liter. Very correct. So the number of moles we have calculated here for sodium hydroxide is for the volume that was used, and the volume is 50. Now we want 1 liter. A liter is 1000 centimeters cube. So we will ask that 50 centimeters cube we got of the mixture is the number of moles which are containing 0.01 moles. You will simply ask 1,000 centimeters cube of that mixture, or that sodium hydroxide would contain how many moles? 1,000 times 0.01 divided by 50. This one will give you 0.2, because it is moles in 1 liter. That one is molarity, because you would simply write 0.2 mole per liter. Mole per liter. Therefore, that is molarity. Calculate the percentage of sodium chloride in the mixture. What is the percentage of this the impurity sodium chloride in the mixture? Now we have the molarity in a liter. That is the molarity. So what we want is to calculate the mass of sodium hydroxide itself in 1 liter. We will use this triangle. I think you have seen it several times. I will use this triangle that says that molarity, mass in grams per liter, RFM, right? So now I want mass of sodium hydroxide in 1 liter, in a liter. First, how do we get that? Mass of sodium hydroxide in grams per liter. So mass in grams per liter is equal to molarity times RFM. Molarity we obtained here, which is 0.2, and the RFM of sodium hydroxide is 40. This one gives us 8 grams per liter. So it means that only sodium hydroxide in the mixture contained 80 grams. But the mixture, so sodium hydroxide plus sodium chloride mixture contains 8.8. So it means that sodium chloride itself contains this one. So sodium chloride equal to the mass of sodium chloride will be 8.8, the total, subtract 8 for sodium hydroxide in 1 liter itself. So this one will give us 0.8 grams per liter of sodium chloride. But we are asked to calculate the percentage. So the percentage for sodium chloride is the mass, we divide by the total, 8.8, we multiply by 100, and this one will give us 9.09%. So that is how. So thank you very much. Please, there are other links in the description. Don't forget to subscribe. I love you very much. Thank you for your support.